Hello. This video introduces MATLAB Structures. Let's first review MATLAB classes in general. MATLAB includes 16 different data types or classes. Each of the classes are in the form of an array or matrix. Remember, everything in MATLAB is a matrix or array. Each of size at a very minimum 0 by 0. So if we take a look at the MATLAB fundamental classes, that includes them growing out of a matrix or array as the base, logical data types, string data types, numeric data types, tables, cells, and structures. As you know, a matrix in MATLAB contains elements. 2 by 2, a size 2 by 2 matrix has 4 elements. But the requirement in MATLAB, each of those elements have to be the same data type. So if you have a numerical matrix, they all have to be the same numerical data type. If you have a logical matrix, all the elements have to be of the logical class or data type. Structures and cells in MATLAB relaxes that requirement. They allow you to store different data types and assign it to a single variable name. Cells have containers called cells, and each cell or each container can have a different data type. And a structure has containers, if you will, but they're referred to and they're called fields. And each field can store different data types. And each data type, it could be different sizes. And so to access one or all the field indices in a single operation is an attribute of the structure. But what's really useful is the structure has a field name. So it doesn't have, say, a layer of abstraction where the cells or containers, if you will, if you're in a cell array, are indexed with subscripts. In the structure, the field has a name associated with it, not a numerical subscript or index. So let's take a look at that in more detail. In this example, consider a veterinary practice. And we want to create a structure that's going to contain data of the patients. So the variable I have on the screen is patient. This is going to be the structure name. But it's reasonable to assume that the veterinary practice is going to have numerous patients. So I'm going to start off, I'm going to use parentheses, so the structure name is patient. And I'm going to say patient number 1. And now patient number 1 is going to have a field called name. So I use a dot notation. Patient number 1 in parentheses, dot name is going to be analogous to the container if it was a cell array. But in a structure, this is referred to as the field. So in this case, the field name is name. So the name is a text, so Cody Del Vecchio. It's a string. I'm using double quotes. So see in my workspace, let me adjust the column sizes here. What happened? So I created a struct, class struct. It's a size 1 by 1 struct, and the name of the structure is patient. So I'm going to double click on patient and open up in the variable pane. And I see the field name is name. And my tab is the structure name patient, field name, and the value is a string. The next field I'm going to create is a field canine. So in the veterinary practice, this is going to be a small pet, so we're going to have names for fields for canine and feline. So is Cody Del Vecchio a canine? Yes. So now what happened? My field is being, a new field is added to the patient structure, and along with the corresponding value. And there's an icon by each field. So we have a string name. Here we have canine is a relational operator. And if I stand on it, a pop-up shows up. It is logical. If I stand on name, it's a string for the values associated with that field. So I'm going to introduce another field called feline. In this case, it is a false, since we already determined that canine was true. What else would be an appropriate field? How about breed? That would be useful information. In this case, Cody is an Irish Wolfhound. So that's a string, so we have a new field name added to the structure patient. I'm going to continue and add, how about age? Yes, that would be useful for the veterinarian practice to know. So now we have 2 strings, 2 logicals, 1 numerical, and Cody was a well-established patient, and he has some test results. So test results are in the matrix form. And due to the HIPAA laws, we can't reveal the test results for patient confidentiality, so we'll just use them generic numbers. And maybe an important information for another field is billing. So how much did the test results cost the patient? And keep track for the quality department. Let's introduce a field called invoice. So was the invoice sent out at the appropriate time to the patient? Yes, it was. It's a Boolean logical operation. And now is the invoice past due? No, it is not. And so we're going to enter that information. So in my variable window, corresponding to my workspace, we have a structure named patient, and it has dimensions 1 by 1, and it has 9 fields. I'm going to use the who's command, and it just highlights the fact the same as my workspace pane. Class structure and size 1 by 1. If I enter patient, it echoes back the field names. It says it's a structure, has the field names and the corresponding data associated with it. So let's add information from another patient. In this case, the patient name is Sophie Jones. So notice what happened. So the structure patient is now size 1 by 2. They both have the same number of fields, 9 fields, and it's populated with the appropriate data. Iconically, we have a string for the name, logical for canine, logical for feline, string for the breed, age, it's a numeric by default. Remember, everything in numeric in MATLAB is a double data type. Test results is a matrix, and it's different size matrix, so we have a variable icon indicating that. Billing, numerical data type, another 2 more logicals, invoice and past due. And obviously we can continue on to add new patients, and we're indexing the array, the structure array, by the index 2, right? So the next one we would increment to number 3, patient number 3, enter in the field names. So let's take a look at that. If we have patient number 3 dot name and Fluffy. So by design, right now, the only thing we know about Fluffy is the name. We don't know if it's canine, feline, breed, age. Fluffy has an appointment but hasn't arrived yet in the practice. But that's okay, because when we add the new array, add to the array, number 3, it just populates all the fields with empty data types. Not a problem, right? So now the size of the structure is 1 by 3, staying with 9 fields. So how do we access information or the data from a structure? So we have patient. If I enter, it echoes back to me. It says a 1 by 3 structure and has fields, name, k-line, feed. So I'm interested in test. Well, what test am I interested in? What patient am I interested in? I'm interested in right now patient Sophie Jones. So that's the second patient, the second of the array. And if I enter that, now I can see all the fields with the data associated with patient number 2. What is patient number 2's name? And I'm using autocomplete with tab here. Patient number 2 name is Sophie Jones. And the next field, let's say test. Has 2 results, 41 and 10. So if I were creating a program, I might want to put this to a variable because now I'm looking at patient number 1. Which was Cody, and we have a new regime of test results. It may be interesting to make a bar graph of the test results to check on the progress of the patient. Again, due to confidentiality, I can't reveal what the tests are. But now I'm accessing, right? Patient number 1 is Cody. Dot test is the matrix in the field test. And I created a bar graph. And I created an assignment statement using b is equal to bar for a reason here, which we'll see. So we do indeed, I'm going to dock this so we can work on it, right? So we have a figure, and in the figure is a bar graph of the test results for patient number 1. So what the bar graph is showing here is the first row was 40. And this first row, first column, 40. First row, second column was 22. Comparing bar graphs, so 64, 65, and then 50 and 98. So there's really 2 sets of data in there. We have bars, the blue bars and the orange bars, right? So B is indeed a structure of properties of the bar. So if I do B1, this is just like the structure we created with patients, right? So we have B is a 1 by 2 bar array. And if I access with parentheses B1, it returns the properties of bar 1. And I see the data values are 40, 64, and 50. Which if I go to my structure field, I have 40, 64, and 50 in the matrix. So patient 1, so I'm going to access patient 1 test as a matrix, 3 rows by 2 columns, and the first bar graph as the first column of data, 40, 64, and 50. Let's go back to the figure. B1, I see face color is a property, and I want to change it to red. Red, 0, 0. So we have red RGB vector, 1 for red, 0 for G, green, 0 for B. So now I'm accessing and assigning a new color red to the face properties of B1, which is the blue group, right? The blue bars. So now the blue bars change to red. I could very easily go to B2 and make them green. So the properties are the properties of the bar chart are structures, and it's a very convenient way to access and modify the structure properties. So if I go and click on I'll show all properties. So B2 properties, this is the greens right now, right? Here's a list of all the properties, and we can see that they are indeed different data types or classes and different sizes. So we have a character for bar layout, and there is here's our face color that we changed to green. Here's an interesting property, horizontal off. If I modify the property horizontal, now the horizontal property is on, and I can access that. It's telling me it's on, and it tells me it's an on-off switch state enumeration, so it's on, and so the bars are displayed horizontally instead of vertically. So this is a very powerful feature in MATLAB, accessing the graphics properties as structures with the dot method, especially for programming. Because you could programmatically change these with variables inside your code, and it updates the charts instantly. You don't have to replot. It doesn't demand a lot of editing using the older direct method for properties in the plot function or bar function. I really encourage you to be familiar with that technique and use that technique as structures with the dot method to access the properties. It's very efficient, and it's a relatively recent improvement to MATLAB, and so I encourage you to practice it, research it, and get proficient at it, and it'll really enhance your graphics capability programmatically to create programs, to create very interesting graphic results in MATLAB. So let's take a look at another way to create data structures in MATLAB, and that's using the structure function. Pull the help page up. The function is called struct, S-T-R-U-C-T. It creates a structure array, and it's very useful for programmatically creating your functions. In this example, I'm going to create the structure called nameplate data using the function struct. And so when I type this out, I have a pop-up window that's going to walk me through this. And the second choice here is telling me is I have a field and value. I can create an empty struct. Let's do that, right? An empty struct, a field and value, and multiple fields. So field 1, value 1, up to field n to value n. So in this case, I'm going to create a field called volts. I'm going to use the escape key to get rid of my balloon window there. Volts is my field name. So what is the value for the first field? Well, I'm going to make a matrix array of voltages, values, 120, 240, 480. I have a comma, so that's field value. The second field, current, is a string. Another comma, and now say 10 amps, 5 amps, 2.5 amps, comma. The third field is a motor, comma. This value is a logical. Yes, it's true. It is a motor. And the next field, serial number, comma, SN, it's a string, 450001, and then close with parentheses. So we could see the graphical feedback. We have our strings and numerical values, Boolean logical types. So this is the field name, the value associated with the field 1, field name of volts. Current is the field name, it has the value. Motor is the field, has a value. Serial number is the field, has the value. And sure enough, we have a 1-by-1 structure, since we only have nameplate data for 1. So if we have 1, surely we could have 2. We create 2, right? So in this case, populated the appropriate information, but in this case we have different voltages, different currents. And is it a motor? No, it's false. It's not a motor. And we have a different serial number. If I double click on my variable and my workspace, now I could clearly see structure name is nameplate data. We have fields, 1, 2, 3, 4 fields. And it's a 1 by 2 structure because we only have 2 entries right now. But we can make that 1 by n. We could add structure number 3, structure number 4. Now in this case, unlike a cell array, we can't directly create and expand without the field names. So we would have to make a 1 by 3 structure, add the fields to the third nameplate array. So to access the nameplate data, I have 1 by 2 structure with the fields. If I want to access the second element in the array, and I want to find occurrence, I use .current, that's the field name, and it returns the values for the field current. If it's the serial number, use .serial number. So we have the structure name, .field name, and it returns the values. What happens if we don't specify which element of the array we want? So we have nameplate data .serial number. It's going to return all the serial numbers in the structure. In this case, we have 2. So each field can indeed contain different data classes and different sizes. Another interesting topic with structures that's very useful for programming is referred to as the I'll call it a dynamic expression. It's generating field names from variables. So programmatically, if you're writing program and you don't, it allows you a very efficient way to create the field names using variables. So I'm going to create a for loop to create the structures for a structure called automobile. So for example, I'm going to have a variable here named manufacturer. This is a string array. Of 3 manufacturers, Ford, GM, and Nissan. And then I have another variable called MPG, MPG is a 3x3 matrix. And now the next variable I create is model. So it's a string array. It is also a 3x3 string array with different models corresponding to each of the manufacturer, right? So the first row corresponds to models for the Ford manufacturer. The second row contains models for GM, and a third is models for manufacturer Nissan. Let me show you the plan here. I have a for loop that I'm going to go through 3 times, and this is going to go through the manufacturer, since we have 3 manufacturers. And so I have automobile dot. This is going to be the field name, but it's going to be dynamically through a variable, right? It's going to be manufacturer 1, manufacturer 2, manufacturer 3. And so manufacturer 1 is Ford, manufacturer 3 is GM, manufacturer 2 is GM, manufacturer 3 is Nissan. And then we have car field and MPG field, and then it's going to populate the data. So what happens? Let's see, automobile. So now we have a structure called automobile, and it has 3 fields. If we go to the Ford field, right, now we have 2 fields, automobile.ford car, and it has the automobile.ford.car, it has the model. And if we go back to MPG, we see the corresponding values for the miles per gallon that created for each of those vehicles. And this is just arbitrary data that's created. If I just type in automobile, we see we have a structure with 3 fields, Ford, GM, and Nissan. Right? Those field names are created programmatically through variables of manufacturer. Manufacturer is a string array. It has 3 elements, Ford, GM, and Nissan. So it's a very convenient way in programming to create fields programmatically with the variable names. If you needed to update this, say you wanted to add a new manufacturer, you could add to the manufacturer string array and then increase your increment to 3. You update your data variables, and you could run your program. And it'll create the structures with the new field names appropriately. If I want to access manufacturer GM, I use the dot notation, so I got automobile.gm, and so now that is a structure with the corresponding fields, car and MPG. So we have 3 levels here, right? We have 2 dots. So now I have a string array for the 3 models, Corvette, Sprint, Impala. So you can see that it's a very convenient way to organize the data, because each field name has a name associated with it. What container do you need? What field do you need? Well, the name is associated with that. In this case, I'm looking for the field GM, and I'm looking for the field car. So I don't have to have, say, a memory map or notes or comments in my program to know that this is element number 3, 4. So that's GM car. Well, the field names are explicit. Automobile.gm.car points exactly to the data in the string array. If I want to index the first one, I can simply use my parentheses as we do in the other arrays. The third, using parentheses. So again, we have very powerful and convenient way to assign group of data with different data classes or different data types to one variable name. In this case, it's the structure name, automobile. Let's take a look at another example. In this case, I have a structure BOM, but I'm using the structure, struct, struct function. I have the field name and the value. Field name, part name. The value is adhesive. The second field is brand name. The value is rigid seal 100. I have another field called stock, so I'm saying we have 5,000 units, 5,000 in stock. What is the unit? These are cases, so 5,000 cases. And the last field is number per case, so there's 24 items of the adhesive in the case. So we have a struct with the fields part name, brand name, stock, unit. Now I did something here by design, right? The brand name, if you notice, has spaces. So the question that we need to ask, can we have a string with spaces for the field name? So for example, say my field part name. I want a part name. Part space name is my field. Can we do that? No, we can't. And MATLAB's nice enough to tell you that that is an invalid field name. So the values can be different data types, but the field names cannot have characters, spaces in them. Do we have a character and in there? No. So the field names follows the same rules for our variables. No special characters or spaces. Okay, so we're all back there. So let's create the second element of the structure array, BOM2. So now we have a 1x2 structure. For BOM. And let's create another one, 3. So 1x3. Open up in my variable pane. Clearly we see fields, part name, brand name, stock, unit, numbers per case. I'm going to create a simple for loop. I'll highlight this after I run it. I've ran out of space here, right? So I'm going to display the sprintf and show the results of our report. So we have 5,000 cases of rigid seal 100 in stock, and the total number of tubes in stock is 120,000, and 15,000 cases of rigid seal 250, and we have 20 cases of Dynaseal 450 in stock, and the total number of tubes in stock is 240. So let's take a look at that. Code. I'm trying to get it all to fit into the screen here. So here's the code I ran and using the sprintf function. I wanted to highlight the fact, maybe I'll just, we have three variables. Structure BOMI, since this is in a loop, and the field name stock. Brand name. And now I'm performing some math on what? So I have BOM dot number per case times BOM dot stock. I in this case is going to be 3, so we're multiplying the 240, result of 240, right? Let me see, I is 3. If I were equal to 1, I recalculate that. Now BOM per case for number 1 is 240. And how much is in stock? We say 5,000. So we're multiplying 24 by 5,000. So Structures are convenient data type, very similar to cell arrays, since we can store various data types of different sizes and different classes and assign it to one variable name. So we can group these together very conveniently. We can pass these variables into functions. The best attribute with structures is the containers or fields have field names, which are very useful to describing the data associated with, or the value associated with that field, right? Because remember, in the structure we have a field name and a value, a field name and a value. And programmatically, it's very useful at times to create the fields from variables. And allows you to be very creative programmers. Just to review. And it kind of makes sense, right? Because we had a field name dot, right? But now we have parentheses. So we're indexing really to the manufacturer, in this case, the ith manufacturer name, which is a string. Manufacturer has 3 strings associated, Ford, GM, and Nissan. So now we could programmatically create a field name for automobile, automobile.ford, automobile.gm. And that's a pretty powerful feature in MATLAB to create structures with programmatic variable names. That's the introduction of structures. Thank you.